Welcome back. All right, so today I'm going to take up the second part of the validity lecture. We'd normally do this all in a week or 2 weeks in a regular class. A good bit of the discussion that would normally be inserted in the middle of the slides here is omitted from the video presentation. However, as we complete the discussion board as the week goes on and as we complete the assignments, you'll have a fuller understanding of what it is that we're getting at when we talk about validity. And today, I'm going to focus in on construct validity. So, what is a construct? Well, a construct is a hypothetical quality. For example, extroversion or intelligence, mathematical reasoning ability. These are all different kinds of constructs. And we use constructs to represent an entire genre of behavior. We might not all agree on what each of these terms or constructs mean, but we all have a general sense of them. All right. So what I'd like you to do for a moment is just stop and think about what it is that you would define as the construct of love. Now, each of us has our own definition, but pause the video for a moment and write down your meaning or your definition for love. Okay, so hopefully you've written something down, and when I do this activity in class, I'll ask people, what is love? And so this is actually one of our kind of mini discussion questions for this week, is to describe what you think that construct represents. What we find is that everyone has a slightly different definition, but we would almost universally recognize each other's definitions as being examples of that construct. Now, this is similarly true for educational assessment. When we think about what it is that we want children to learn or what we want them to demonstrate or perform, we think about things like good writing. Well, we won't all agree on what good writing is. Just as I mentioned before, when we think about James Joyce, some of us might think he's a great writer, while others might think, well, this isn't my cup of tea. Let's go on. So here's a definition for you. The construct-related evidence definition is the extent to which your assessment measures the construct, whatever that construct is, reading ability, intelligence, anxiety, that you purport to measure. Now that sounds simple enough. As we dig into this, I think you'll see that it's much more difficult to actually measure a construct accurately and reliably than it is to say that you do. So here are some kinds of evidence for measuring a construct. One of the ways that test developers do this is to see if test items behave the same. So for example, recently I've done some work with, it's an aspiration survey, and it was one developed by some researchers here at the University of Maine, Craig Mason, Shifen Tu, and Sid Mitchell, collaboratively developed this new measure. And it has 41 items, and what it does is it asks students about their future aspirations. Questions like, I'm good at sports, or I'm a good communicator. And then students agree or disagree with each of these statements. One of the ways that they develop this scale is to see if the items behave the same. So they had subscales in this personality measure, or this aspirations measure, that were generated around things like self-directed work. And so there were 7 or 8 items that were all designed to get at the idea of self-directed work. Questions about homework, questions about task completion, other kinds of questions that got at whether or not students stuck to a task and saw it through to the end. Other parts of their scale focused on things like teacher helping behaviors. And so there were a series of questions that asked students to describe whether or not they thought their teachers were looking out for them or willing to help them. So each of these subscales was a construct, the idea of teacher helpfulness or self-reliance, perhaps. And what they wanted to see was to see if the items that they had designed, that they had written, behaved the same way. In other words, if a student was likely to say that they were good at getting their homework done, were they also likely to say that they were good at completing tasks that were self-directed? So if they answered items in a similar fashion, then it would seem that the items were measuring the same construct. Another piece of construct-related evidence is to think about the mental processes that are required to answer a question. So, for example, if we have similar types of mathematical problems, the same types of mathematical reasoning might be required to solve each of those problems. So we would logically expect that those questions would have similar constructs underlying them. Now, there are things that can get in the way of that. We'll talk a little bit about some of those things. So it's called construct-irrelevant variance, and we'll get to that in a moment. We can also compare the scores of our group to the scores of a known group. So let's say that we're trying out a new set of SAT questions, so it's the Scholastic Aptitude Test. And we want to see if our new questions behave in a similar manner to questions from previous tests. One of the things that we can do is we can look at the performance of a known group that's already taken this test on our new questions. We can also compare scores before and after a treatment. Do they change in the way that we would have expected? Do they change in the way that our theory states that they would have changed? So if we think we've done intensive reading comprehension work with children in an early elementary classroom, do their reading comprehension scores go up? Another piece is to take a look at correlations with other constructs. Do they correlate strongly with similar constructs, and do they correlate weakly with dissimilar constructs? Okay, so one of the things we're looking at here is, let's say that we know that mathematical calculation ability and mathematical reasoning ability should be highly correlated, but it might not necessarily be so that mathematical reasoning ability and writing ability are directly correlated. So we would want to see convergence between, say, mathematical reasoning and mathematical calculation, but we might want to see some construct divergence between, say, writing ability and mathematical reasoning ability. So, some important points about construct-related evidence. We usually try to assess this after the fact, okay? And generally, it's something that requires test scores. So it's not typically something that teachers will do. This is generally a fairly involved process. This is a process that large-scale tests often go through to establish their validity. This is one of the 4 types of validity evidence that's required generally for a test to be published and to be widely accepted. It's an extended logical process. It really can't be quantified precisely, but there is an extended logical sequence of steps that test developers go through to establish the kinds of things that we mentioned just on the previous slide. It's difficult, if not impossible, to prove. Okay, so I'm going to come back to my example again. So what is love? You wrote down your definition. What's the operational definition that you would give for love? What are the characteristics of love? And is your definition all-inclusive? Probably not. As we look at the discussion board, I'd like to see you go to that. You might go and take a look at that now. One of the things that I'm going to ask is for each person to state, what is love? And it's not because I'm interested so much in what one thinks about this, but in the divergence of different opinions, but yet the convergence of similar features. So take a look at this cartoon. So Calvin and Hobbes has always been one of my favorite comic strips, and I love how Calvin has a different definition for love, or a different set of symptoms than we would normally ascribe to that. But yet when he says it, it all makes sense. So constructs are difficult to measure, and when we think about things like writing ability, and we think about things that are typical constructs that we measure in school assessments, then it becomes even more difficult for us to agree, even as professionals, as to what is the evidence that we need to show or to demonstrate that we've met that construct, that we've really fully described it in the way we've measured it. Another kind of contributing piece to this is the idea of having a criterion. And a criterion is a valued performance or a valued outcome. For example, scores that are high on a standardized achievement test. And we find that they later do well in an algebra class. We believe that this might or it should be related to what we're measuring. So when we do well in a math test, we would then later expect the child to do well in algebra. So this is sort of a criterion relationships issue where we can almost build a contingency table. If we say that students who perform extremely well on the SAT then go on to do extremely well in their first year of undergraduate education, whereas students who do poorly are much more likely to do poorly in school. Now, this seems pretty simple. On the other hand, figuring out what the exact nature of these relationships are is a far more complex process. But when you hear about people talking about a contingency table, what they're probably talking about is this idea of criterion relationships, that high scores on one thing are often related to high scores or high performance on another measure, like the SAT and first-year performance in college. So here's a little bit more of a definition for you. This is the extent to which your test score correlate with some valued performance that's outside the test, that criterion. So we could do concurrent correlations where we're relating your score on one measure to a score on another. So how does a student score on the National Assessment of Educational Progress, or NAEP, in math compare with their grades? So if kids are doing well on this national measure, even though kids don't actually get individual scores on this measure, does that relate to them doing well in their classroom grades? Another is this concept of predictive correlations that I was just talking about. Can we predict a future performance? Like, for example, how well does the SAT predict performance in college? What about one's high school grades? And we in fact see that high school grades are about equally good as the SAT in predicting how well you'll do in college. So, next slide. I want to make a clarification here. And that is that this idea of criterion relationships, in other words, predicting some concurrent or future outcome, is different than using the idea of a criterion or criterion reference test. So in the case of the criterion reference test, we're stating what the objective is that we're measuring in the test. So for example, the MEA is often described, or the main educational assessment, is often described as a criterion reference test where there are specific performance standards, performance indicators that we're measuring. And so that questions can be linked directly to that outcome. So this is very different, where in one case we're saying in a criterion relationships comparison or validity measure, we're looking at how well does our measure actually link to some concurrent or future performance. Okay, so to wrap up some of the issues around criterion-related evidence, first of all, it always requires some sort of test scores, or some kind of assessment score, I should say. It doesn't have to be a test. But performance on one thing is related to the performance in another arena. It's quantified, that doing better somehow numerically or score-wise will lead to a better or a worse performance on some other measure. So higher scores on the SAT, higher GPA. Probably the most important thing is to think cautiously about criterion-related outcomes. One of the things that's very problematic is when we summarize data across large groups. For example, we could look at the performance of students from different racial backgrounds, and we could create what are called expectancy tables, where we know that perhaps students who are from one racial background tend to do better than students from another racial background given their performance on a certain test. So it's easy for us to create an expectancy table, or in other words, for us to create a prediction about how well you're going to do based on the fact that you're male, you're between the ages of 30 and 45, you're perhaps a non-smoker, and you're married and you have 3 kids. And so insurance companies use expectancy tables all the time to assess what they call risk ratios. Well, we can do the same thing in education. But it's a dangerous practice because it's a summary across many individuals. And what we find is that when we make generalizations across large groups, although they hold up and they're true for the group, they're not necessarily true for the individual students. So we think about equity and opportunity for kids. When we create specific cut points based on assessments that allow kids into or not into some program, that cut point has got a degree of error involved. It's a good prediction overall, but it may or may not be a good prediction for a specific student. Another related point is that it's often hard to find a good criterion or a good measure or a level to set. So when we set a cut point on a test, let's say that our cut point on the MEA is a 560. Okay, so we're taking the 5th grade test. 560 is perhaps, we'll say, exceeds the standards. That's a very good score. But if we were to only take children who had earned a 560 and admit them into our GT program, we would potentially miss some students just through other kinds of irrelevant factors like unreliability or the spread of scores. We would find that we miss some students who are otherwise qualified. We'd also find that some students that got that 560 actually weren't all that qualified to be in our GT program. So when we create expectancy tables or we use the scores on a test to essentially allow us to predict how well we think a student will do in a later performance, we're going to be wrong some of the time. And that's a critical piece to recall as you're thinking about criterion-related evidence for validity. The next piece is pretty straightforward, and this is the idea of correlation and correlational validity. And so we know that a correlation is a measure that indicates the degree of relationship between two sets of scores or two variables. So we know that people who are taller tend to be heavier. We also know that to some degree people with more years of education tend to make somewhat more money. But none of these relationships are perfect. We know very tall, very, very thin people. We also know shorter people who are not particularly thin. So we call these things coefficients. And so a validity coefficient is this idea of using the calculation between a criterion-related piece of evidence. So going back to our expectancy tables, a reliability coefficient is, we'll talk about in much greater detail next week when we talk about reliability. But this is just how reliable are the scores from point A to point B. Internal consistency we'll talk about. There's a variety of measures of ways that we use correlations to assess reliability. So we'll look at those more as we discuss descriptive statistics in a brief manner later in the class. The last type of validity consideration that I want to talk about is this concept of consequential validity. And what are the effects that your assessment has or fails to have that's important for you and the other people involved, particularly for, in the case of education, for our students who take our tests, what is it that our test is going to do? Now, I talked early in this lecture, or even in the introductory lecture for the course, I'm not actually sure which, but I talked about the idea that the shift from to the MEA in 11th grade and the adoption of a local assessment system had some unintended consequences at the high school level in terms of the level of seriousness with which students were approaching the 11th grade state test. And what I mentioned then was this idea that the state decided to adopt a local assessment system with the concept that it would increase students' investment and schools' investment in ensuring that students had achieved the learning results. Well, what happened were a series of consequences, some intended, some unintended. And what we found instead was that schools began to really narrow their focus on the specific things that would be measured by the MEA and would be measured by the local assessment system. And this was, of course, concurrent with the adoption of No Child Left Behind. And what we really saw was this idea that in some schools, the curriculum narrowed significantly. And I've had many teachers tell me that they thought that that's been the case. Certainly things like social studies in history have been de-emphasized, while other core subjects like mathematics and reading and to some extent science have been emphasized. So what are the consequences to our assessment and to our approach to assessment? So in this case, some of the evidence definitions, you could think of it this way. What is the extent to which your assessment serves its intended purpose? Does it improve performance? Does it avoid negative side effects? Or does it distort, or does it wind up distorting the curriculum? Did it improve their performance, the students' performance? Did it improve their motivation? Did it change their level of independent learning? Did it change our instruction? Did it distort it? Did it improve it? Did it encourage or discourage creativity or exploration on the part of students? Did it focus us more on content-based learning in terms of factual information, or did it encourage higher level thinking? So there are a whole series of questions that we need to challenge ourselves with as we think about when we assess students, we are sending a message. There's an old adage that says, what gets tested gets taught. And I believe that that's in a large measure true, that teachers have kind of oriented themselves to provide instruction around those things that are measured and that are given the greatest weight. And that's not necessarily good, but I believe that that's largely the case in schools. So when we engage in testing and we engage in measurement, what is it that we're valuing and what is it that we're not valuing? Because it's just as important in terms of what's left out. So another one of our conversations is going to revolve around this idea of what is the value of assessment and measurement? And what is it that we show we value and what is it that we don't show we value in our schools? So a few of these important points about consequential validity. It's usually gathered after our assessment's been given, and often we don't really know what the consequences, both positive and negative, are going to be until quite a bit after our testing is done. We might interpret our scores correctly, but we still may have a lot of negative side effects that we didn't intend. We have to weigh the consequences of not using that assessment. Just as I mentioned a moment ago, by not testing something or not doing something, that's also sending a message, and it has consequences. Inaction is as significant a step as action. And then finally, judging these consequences is really a matter of values. It's not psychometrics. There's not a right answer. But we have to arrive at some common socially constructed set of values where we decide what we think is important to test, what we think is important to value in our schools, and what isn't. So, what are some of the sources of threats to validity? And threats to validity are all of those things that undermine the validity of our assessments, of our inferences, I should say, of our assessments. And tests themselves are a threat to validity because tests are an artificial experience that students are expected to engage in, to measure something that we're going to believe is real. Teaching is a threat to validity in that if we are teaching to a test, then we are undermining the actual test. What we want is for students to generalize knowledge, not to be able to perform a specific task on a specific test. Administration and scoring is really a reliability issue, but poor reliability also means poor validity. Students are a source of threat to validity in that we may or may not have students that have the same sets of skills, and so it's a different experience for each student that takes the test. The test may be appropriate for one student, but it may be quite inappropriate for another, based on that student's background, their approach to the test, their attitude towards the test. And so when we find a student that doesn't have the appropriate background or the appropriate attitude about taking a test, we could actually find that we have an invalid result because they weren't really trying or they weren't really prepared. And then finally, what's the nature of the group or the criterion? Are they actually aligned in terms of the purposes to the content and the delivery system of the test that we're thinking about? So can you give some examples of each of these? And again, I'm going to fold in several of these questions from this validity lecture into a series of kind of mini questions that we'll undertake in our discussion board. All right, so here's our break, and we're going to stop here. I want you to turn to the discussion boards to follow up with some of the questions that I posed there that stem directly from this lecture, and look forward to doing the next section, which is going to be on reliability.